Hello, everybody. Hello, and welcome to another Data Heretics live session with Joe, Dave, and Ku, and myself. It's really great to have everyone here. How's everybody going?
Doing good.
So, if you're tuning in, please let us know where you are watching from and what time it is. It'll be really awesome to start seeing some of the comments coming in. Oh, we've got a few already. Oh, awesome. Great. So I hope this time works for people. This is one of the best times for us because we're in all different parts of the world. But yeah, I really hope you guys get a ton of value out of what we're doing today. So without further ado, today we're going to be talking about machine learning pipelines. So the first thing that we should do is kind of define what we're really going to be talking about today. So I might open the floor to everyone here, and in the comments you can feel free to let us know if you have any questions about machine learning pipelines or anything that we say. I'll keep an eye out for all of those as well. So who wants to take what are machine learning pipelines?
Well, why not Joe go ahead first?
Sure. Yeah, so I think simply put, machine learning pipelines are workflows that help you orchestrate, transform, and move data along a path towards productionizing a model. So that can be used by an end consumer, whether the end consumer is an API REST point, maybe a batch prediction that flows into a system, or any other use cases. But basically, it's a systematic workflow for machine learning.
Okay.
Ku, you want to go?
All right, I'll go first. Sure. Actually, yeah, to me, I think machine learning pipelines is more on the processes and the processes on implementing the machine learning models into the system. But actually, I like to be upfront over here first. My experience with that is actually quite minimal. Mostly more on the business and strategy part of things. But so I just try to share as much as I know about. But I think the experts are the three of you. Yeah, Dave, why don't I go next then?
Yeah, so I would say a machine learning pipeline is a reference architecture for taking a machine learning solution for the enterprise to production in a cost-effective way. And that's sufficient. Can you tell I used to be an enterprise architect or what? Because that's like really vague.
Yeah, good job.
Yeah.
So, I mean, somebody in the audience, Monica asked, are they like ETL pipelines and data warehousing? I would say not really. I think they serve different use cases. It could be that an ETL pipeline is part of your machine learning pipeline, but it's one component. An ETL pipeline does serve the business with the data warehouse specifically, normally. So, yeah,
conceptually similar, but more to it, generally speaking, than just an ETL pipeline in a data warehouse.
I think for me, you go, Ku. Sorry.
No, sorry. I think it's more on the what I think now there's like some separation of things. Is the ETL pipeline will be more on the data ops side, right? is that such a term called data ops over in?
Yeah, we have that here.
Yeah,
Mhm.
yeah.
Yep.
So I think the ETL pipelines is more on the data ops rather than the ML ops. Although I think there's still some some connections over there, some relationship over there. Yeah.
There's a lot of
That's how I
overlap
see it.
still. I think ML ops and data ops, I think, are sort of still terms being fleshed out. So
Yeah.
we'll see where they land. And then you get into like machine learning engineer, and then ML ops, and like what's I don't know. So it's kind of reminds me where software engineering and DevOps were like 10 years ago. So, but the machine learning field is still really new. So Ion, I think is the person's name, asked what's the difference between a data pipeline like Airflow with an ML pipeline. So Airflow is more of an orchestration framework, right? So it's pretty agnostic whether you're using it for ETL, ELT, or ML workflows. We see them being used for all the above, actually.
I think before we dive into, I clicked the wrong thing. Before we dive into more of the talk around the ops and where it sits within the systems, I think for a lot of our audience, we think of machine learning as, okay, we go into Kaggle and we run some machine learning pipeline where we get some predictions and we suck in some data, do some pre-processing, do the machine learning, the fitting of the model, and then out comes some model, and then you make predictions of it. I think because there's this concept of machine learning pipelines in that sense, where you've got data and then the pipeline produces some prediction. There's also a lot of, I would say, maybe not miscommunication, but misinterpretation of what an actual pipeline is and how different people define it. So if you're talking to some, let's say a data science enthusiast who is doing a lot of Kaggle, their process of training and fitting their model will be considered a pipeline. And in some ways that's very correct and adequate. For example, when you're doing some of the feature pre-processing, they also have, let's say in scikit-learn, for example, there are things called pipelines, which you can put in different steps into those pipelines also. So I think when we talk about machine learning pipelines, there's a whole vast array of things which it could mean. And I think this is why it makes it really difficult for new people coming into our field who want to do machine learning. And then they read all these different things about, oh, this is a pipeline, this is not a pipeline. I think that's where it's really challenging for everyone. What do you guys think?
Maybe let me go first then. Sorry.
No, go ahead, Ku, go ahead.
Okay. So generally, what I always tell, so like when I was running when I was in the master's program or when I'm doing my courses and training, I always tell people, I say that don't take my word for it, because how I look at things will be based on the experience I have. So as much as possible, try to find out more. And I always use this example about the 5 or 6 blind men touching an elephant. So currently now I think the elephant could be like the ML pipeline or could be the data pipeline and all this. Everyone is like trying to get a feel of it and also at the end of the day, ask more people, try to understand a bit more and form your own opinion then. But at the end of the day, realize that there will be differences in the expectation or opinions as well. Yeah, that's how I'll go about doing it. Yeah. So Dave, go ahead.
Yeah, what I was going to say is, this is going to be a little bit nerdy, so forgive me. So you can think of basically pipelines as just a reference architecture, right? There's conceptual pieces that go into it. And you know what? As you described, Danny, if it's, and I'm going to use my frame of reference, if it's somebody that wrote an R script using tidy models and they're competing in Kaggle, they could implement a conceptual pipeline and the whole thing's manual. But conceptually, that is a pipeline. Doesn't mean it's not a pipeline. Just doesn't mean it's the right pipeline for a Fortune 500 company looking to build a production system. That's all it means.
Definitely. We've got a question here from Chris. We were discussing this exact question before we jumped on live. So will we be discussing model ops or dev ops?
Neither.
Or ML?
Neither, because we're going to
ML ops.
We're going to invent Dave ops, and I'm going to write books and become a millionaire. That's what we're going to do. We're going to do Dave ops. Okay.
Well, I personally feel that we don't have to go that well defined, as in like go to so specific niche. we don't have to go that niche. I mean, like what Dave mentioned just now, right? It's more of like once you have it, it's all the surroundings or what are the surrounding components that goes into it. I think that matters the most. And I think our audiences have already known, right? All of us agree is at the end of the day, it's a value that counts. It's a value that counts after that. Not really what goes into a certain parts. What components go into a dev op, what components go into a data ops and all this. I'll say, yeah.
But I think you can look at it as sort of a as Dave indicated, there's what you could do as sort of a first step, right? Which is just making a pipeline sort of from scratch using your common ML frameworks, and that's probably fine. And if you look at it sort of on a continuum, right, that may be a very manual way of doing things. And then, of course, as you become more sophisticated, maybe you're moving outside of a toy project, then you want some automation behind that, right? So you want the ability to retrain, automatically redeploy, and then I guess maybe a stage beyond that's continuous integration and deployment, and that's when you can continuously just deploy models and continuously retrain models as the system sees fit, and it really moves a human from the equation. Now, of course, to get to that stage where you're doing CICD, it's very similar in software. There's a lot of things that have to happen before. It's not just a technical discussion either. Especially as Dave knows, being an architect, there's organizational issues you get to contend with as well, which will sort of help you on your way, or maybe you'll just be stuck doing things manually your entire existence. I don't know.
Yeah.
So
I think Dave Martinez here has actually come up with a really great point. So in other words, what an ML pipeline means depends on who you're working for and what your goal is. And I think that's like very much hits the nail on the head, essentially. Depending on your audience, it could mean something different to, let's say you're talking to Dave, who Ayush has called DevOps, which is great. I think if you're talking to a Dave, he's going to be talking more about the architecture and where it fits in and can you get the value out of it. If we're going to be talking to a Joe who's very hands-on on the machine learning and the systems and the ML ops, he'll be thinking more about the ML opsy thing. Dave's looking really surprised.
I've been writing code since the 1800s, man. Come on, man.
Wait, are we in the second episode or the third episode? No.
So I did have a question for you guys, though, and I was wondering about this because you guys have some more experience in this realm than I do, and I think maybe the folks might be interested in this as well. Sometimes I wonder, realistically, how important is the CICD aspect of ML ops? Hold on, let me finish before you try and tar and feather me. Mm-hmm. Because you often don't retrain and redeploy models that often, in my experience. It's not like you're doing it like multiple times a day or multiple times a week a lot of the times even. What I find more important is actually this idea of like what you're doing is you're putting in your architecture an automated way to detect model drift. And that's more important than CICD, generally speaking. Because that's when you know you actually have to retrain and deploy models when you got model drift.
Yeah, as Chris Ellsworth said in the comments, continuous model learning, I think is, and there's some use cases for that for sure. But it's entirely situationally dependent. If you're Google, Facebook, you're continuously retraining your models. I don't know how and then, but then again, there's situations like I was reading this article from 2018 about Amazon and how it reprices things every 15 minutes or something for like 2.5 million items. I'm sure that number's grown by this point. So it just depends on the situation. Obviously, if you're getting, if there's new data continuously coming in and you got to retrain, then you got to retrain. So you need to figure it out. But I think for a lot of companies, I don't know that you need to do that, but maybe you do.
Well, isn't the assumption there then that your features don't need to change then?
I think it depends. So in that case, you want to have monitoring set up to understand like where you're getting like training and server drift, for example, right? And if you've seen constant separation of the two, then you're going to have to keep retraining. So your features may stay the same, but the underlying data composition may end up changing to the point where retraining is necessary on a frequent basis. So.
So in my experience for the, in terms of the CICD of the model itself, what we like to do is we usually think about one will be the production environment. So your model's there, it's running, it's making predictions, and it's versioned and all of that good stuff. Then on the sandbox side, that's where the data scientists will be continuing their experimentation, trying to work on a separate holdout set and trying to beat the benchmark. So then they can claim, oh, my model is better than this one. Let's bump it up to version 2 and use this new version of the model. That's part of the CI/CD process, but it's very much in different environments. So once you prove that your model has improved, you would then run off the processes to update that model, get the new one in. If there's any upfront and upstream data changes, you would also get those in also in conjunction with the data engineering teams or the machine learning engineering teams to make sure everything flows properly. What we've found is when we get these sorts of processes in place, you would get your data scientists would just focus on building better models. Your engineers would focus on helping them deploy it. So then you can get more scale and value out of whatever work they're doing straight away, almost. But this is more for, I would call it very advanced in terms of where a lot of the systems will lie and where the thinking of the management for these data science teams and data teams have to live also. Like you have to be thinking at quite a strategic level to even conceptualize having these sorts of different streams. Normally you would just have, okay, data scientists, go put your model somewhere, make sure it's giving me predictions to drive my product. And that's the end of it. Like there's no opsy things, there's version control is hardly there. It really depends on the maturity of where the companies are, I think.
Yeah, and I'd also wonder too, like how many data scientists actually have the ability to say, hey, I deployed model A into production, and I'm just going to constantly iterate on that, versus I put model A into production, and now I've got to work on model B because that's the new project I'm on.
I think it's definitely the latter case. I mean, yeah, and I think the discussion, I mean, we can talk about CICD some more, but I think for the audience especially, like, it's a very advanced thing, right? I mean, because you got to remember, if you're an organization that's doing CI/CD for your data ops, I suppose depending on the company, but I'm wagering to guess that you're probably working at a company that has an application that needs maybe a model with continuous learning, right? So that also presupposes that you have some sort of DevOps culture embedded in your engineering team on the application side. Because again, these things don't just exist in the silo. You can CI/CD the models all day, but unless there's like an application that utilizes this model in production, that sort of doesn't mean anything, right? So, I mean, so you got to work with the engineering team as well, is what I'm saying, and the rest of the organization. So when you're deploying models, like, feel free to deploy the model, but at the end of the day, the app still needs to use it. So you gotta. There's a lot of things that come in, like we were saying earlier. It's organizational dynamics, I think, are just as important or more important than even the pipelines in this case.
I think what I'm hearing is, I think there are three things over here. Firstly is how mature the company is. Like, are they using like a lot of models to drive decision? That's one. I think the second thing is also whether the sort of the data they collect, right? Is it always like a lot? Like maybe in Amazon, within like 1 hour, you already collected enough data probably to retrain your whole model, right? That's the second point. I think the third point will be where probably have to look at the regulations and compliances and all this, right? I mean, if you look at like banking, you look at healthcare and all this, especially if you're like building models for risk management, it's not something that you build finish already, you can implement it immediately. There's like all these like audit process that have to happen. You have to get internal audits passed. You have to get external audits passed, and then after that, then you can do the implementation and all this. So I guess it will be these three factors to determine whether we do a CI/CD or not. So to reiterate, will be the company maturity, how many models, the data that they collect, and also the regulation and compliance. That's how I will see it. Yeah.
Mm-hmm. Oh, and presupposes you also have automation in place, so you kind of need to automate everything first. So like work, and this, and Dave would know, especially being a software engineer, it's like there's a lot of testing that goes into building these systems. It's not like you just stand them up. My advice, if you're going to try and go the CI/CD route, whether you need it or not, I don't know. That's your problem. But somebody asked, how does Amazon SageMaker pipelines help with CICD for MLOps? I'm actually going to be checking that out tomorrow. I'm going to be making a nice little unboxing video about this, so stay tuned. I expect it'll work pretty well. It works in, I think it works in SageMaker Studio, which is actually pretty dang nice these days. So I guess my point is, if you're going to be doing any of this automation, and especially if you're in the cloud, just use what the cloud's already provided for you. For you to write this stuff on your own, unless you have a compelling reason to do so, I think it's insane. There's a lot of moving parts. And the teams at AWS, Google, Azure, these are very big teams. They are extremely skilled at building this specific software. That's literally their jobs. And so focus on what you're good at. I imagine a lot of the people here right now are data scientists and want to work on building better models and deriving better business insight and value of the data versus working on the infrastructure behind those insights in the data. So my 2 cents, but get what you pay for.
Yeah.
So
I'm with Joe for sure on that one. Oh, before we move on, I wanted to buzz up Todd's question for me. What does Danny's ML buzzword converter turn ML pipelines into? I would, to make it really short and sharp, I'd say like scheduling my R script.
Wait a sec. Are you trying to pick on me by that, saying that? Is that what you're doing?
I'm an R programmer too, so I think I'm just making fun of myself.
Oh, okay.
But sometimes when I think of ML pipelines, I think of like, in like Mario and Luigi, like ML, and then so you know how they go down the pipes and then they just come up somewhere else. So imagine that Mario goes down one pipe and then Luigi comes out the other side because Luigi is better than Mario, clearly. So, and that's that's a ML pipeline. Just put stuff in and then it converts it into what you need at the end, more or less.
I mean, that isn't too far from the truth, though, I think, for a lot of ML pipelines, especially if you're just using, again, to distinguish nomenclature, right? There's a pipeline in the sense where you're building an architecture framework, right? A lot of moving parts, microservices. That's another buzzword you can add to your thing. But then there's the pipelines that are embedded in the frameworks, right? So sklearn, we already talked about those pipelines. Spark's got the same thing, the notion of a machine learning pipeline, right? It's just an asynchronous workflow. Sometimes synchronous when it's not, but basically it's a workflow where you get from point A to B. And I think it's where most people, in this group are, with this group, I mean the audience, where they're focusing on, okay, so I got some data, I need to make a model. How do I do that?
What do I do? Yeah.
Mm-hmm. Yeah, I would wonder, and again, maybe I'm just being blasphemous here, or heretical maybe, that it's probably more important to understand the conceptual pieces of an ML pipeline rather than worrying about the specific technology first.
Yep.
Because that tells you what you actually need from a functionality perspective, no matter how you implement it optimally for your current situation.
Mm-hmm. Definitely. So yeah. I think I've impressed Todd with my response. It's a solid heresy.
Yeah, it is. Yeah, it is.
Oh, hang on. I'm just clicking random things over here. Monica's suggesting that instead of Luigi, we sometimes get a mushroom, which sometimes happens.
Yeah, that's true.
Are we going down to the computer games route now?
Yeah.
Okay. I think Danny's got an affiliate relationship with Nintendo here or something.
I'd love that. That would be awesome. Okay, so as Joe touched upon, I think for the next section, what we'll talk about is some practical tips on helping you guys, I would say, what are some basic components of an ML pipeline when we think of a data science pipeline? So you have your data and you need to make a model. What sort of components would be in that sort of pipeline? I think between the four of us, we've got enough experience to kind of guide you through a for dummies approach to what you should be doing. And maybe we can also talk about some common mistakes that we've committed or we've seen other people make and that you should avoid. So I think usually when we talk about machine learning and I think for anything that we do in data, it's more about you should learn what not to do because there are many, many ways to do the right thing. But there is, wait, did I say that right? Anyway, you should figure out what not to do because I think that has much more of an impact than trying different things because that's what we should be doing. Like we should always be exploring different methods and techniques and stuff.
Yeah, I think the most important thing in the ML pipeline for a data scientist is data. I know that sounds blindingly obvious. I can't tell you how many times I've seen people, and have done this myself, where you have you don't understand your data well enough, right? Especially, I'm talking structured data. Now, images and unstructured data, like images, audio, text, whatever, that's sort of in its own bucket. I honestly think ML unstructured data is the hardest type of machine learning. It may sound heretical, whatever. I've done a lot of this, so. But I honestly think that it's actually easier to do machine learning on data that neatly conforms to things like pixels or tokens. When you start getting to structured data, there's a lot of interesting nuances to it that you don't find in other data types. We can get into the second. But a lot of it depends too on structured data is human generated data, typically, right? It exists in enterprise systems, usually input by people or maybe machines. But point being, understanding your data set, I think, is the most important thing in getting the right features, is the most important step in your ML pipeline.
Monica seems to agree with this one as well. Data curation is very, very important.
Monica knows what's up.
Yeah, Monica's on the ball. For me, when I think of let's talk about machine learning specifically for structured data. That's my area of expertise also. I think I've seen so many times where it's been done wrong, and maybe not wrong, but it's been done suboptimally, where people just don't take into account what data they're feeding into their algorithms to train with. For me, my pet peeve is when people think about taking their target variable, because when we think of Kaggle and all the different machine learning, like the courses and the different things that we learn from, all the examples, we're always given that target variable. But in real life, it's rarely given to you. You have to systematically generate that target variable when you're thinking about some sort of, let's say, rare event prediction or forecasting or different things like that, where you're bound within a time frame. I think a lot of that it could be taught much better within like all the education, because it's usually we're just given the label, and then you randomly split the data, and then you fit your model, and everything's good. And people focus a lot on the hyperparameter tuning, but a lot of all the gain of machine learning comes from being able to define your problem properly. And the best way to do that is to really understand your data. Yeah, I feel like I'm preaching.
Well, yeah, I appreciate the quiet, but I would say like running tests on your data too, like making sure that your features aren't like highly correlated with your label, for one thing. That's a huge mistake I see over and over. Then people wonder why, God, my model's awesome. It's like 100% accurate. It's like, well, yeah, because like your label's also in your data. So happens a lot, but
yeah. So I would also say one of the basic components of the ML pipeline is on the opposite end, which is not only do you want to make the prediction and give it to the app or the system that's consuming it, but you also want to record it so that you can go back and look at your predictions vis-a-vis the actual behaviors that happen after the fact. Because my experience has been, you build a model, you deploy it in production, and then you're off on the other thing. So it's just sitting there running. So you want to know what it's predicting to see, for example, are you drifting from the acceptable level of performance? That's your business requirement. And then you can get an alert. Or you can see if there's any change in the patterns of the predictions. Are they getting less accurate? Are they getting more accurate? If any of those things are true, why are they happening? So for me, I also like to think a lot about the far end of the pipeline and say, hey, the predictions are not just for the consuming application or system. They're also for me as the data scientist as well.
Yeah, I like to add on to that. I think that there's a common misunderstanding. I don't know why how it happens, but a lot of people, like, they thought that once you build a model, like, you can use it forever, that kind. But we all know that that's not the case. You need to have like that validation component being built in and checked out. That's one. Second thing is also you have to have a very good perhaps an established policy, right? As to like when do you really need to change the whole model, or maybe reuse part of recalibrate the model again with other features, and stuff like that. So I think that one is also quite that component is also missing in some of the companies that I see. So that's one part. If we move on to the data part, right, I do agree with what is discussed so far. One thing that I people that did not really pay attention to as well, right, is if you're doing like supervised learning and all this, you're pretty strict about the data that gets fed into the model. Like one common example I usually tell people is this: if you're using square meter as an area, right, for your feature, you stick to square meters. If you're using like square yard or something like that, then you stick to square yard. You don't suddenly change from yard to meters or something like that, and then the whole model suddenly becomes not predictive, and you blame the model instead of you looking at what you have fed into the model. Yeah. So that's another part. I think for those who are new to data science and all this, right, you have to be a bit mindful. Once you have set up certain features and all this, be mindful about the unit that you use as well. Is it square meters? Is it yard and all this? And then that goes back to what Dave is mentioned about the documentation, right? You have to make sure that you document all this now well enough so that you can replicate it. That's one. Second thing is also where you've gone wrong, and then you can improve upon what you've learned.
Got a couple questions here. Oh, I was going to answer them.
Was this the one that you wanted to answer?
Well, there's a couple of them, but this one's good too. I think that so the world of machine learning is, I think, becoming very interesting in that it's splitting up. It's becoming fragmented, right? The days of like the full stack data scientist, if that even ever existed, I think is going away for most companies. And what's happening is, I think, machine learning is going to split into different areas. You can be a ML researcher, which is focusing on algorithms and developing new algorithms. I'd say that the skill you need there is just, you need a lot of skills there. Good math skills, good research skills. I would say good learning skills can be learning a ton and communicating with other researchers. But that's one area. ML engineering is another one, where I think that's definitely another area, but that's more focused on, it's just you got to know a lot of machine learning, I would say, enough to be able to know that the infrastructure you're building and supporting will work for machine learning. And I think the third place that it's moving to is basically an analyst / domain expert who's really good with data. And so that person may or may not be using machine learning, but they probably will be, right? I think machine learning in most companies will just be pretty standard fare, but that's where I think it's split. So it's kind of a nuanced answer that I think, but it's a nuanced question behind the scenes. To be an ML expert these days, I think it requires going down different paths. I don't know that you can be awesome at everything. I talk to people who are ML researchers, and it's not what I do. So, right. And when they talk to me, it's the same thing. Like what I do is not what they do. And so it just depends what type of ML you want to get into. So, and I
would wonder too, ML expert is going to be in the eye of the beholder. So maybe it might behoove you to decide who do you want to perceive you as an ML expert. Because, for example, if you're talking about doing research like Joe's indicating at Google, the hiring manager is going to have a different level of expectation of what that means vis-a-vis somebody in the business. So if you work with a business partner or you want a business team and they view you as an ML expert, it's going to be a completely different set of skills. And generally speaking, what I would argue is what is mostly needed is actually probably folks that have both a certain level of ML skills, probably far less than what some people would consider expertise, and then marrying that up with business knowledge. And then they can be practically extremely useful for the business. And then they'll be considered ML experts in those eyes.
Yeah. Yeah. I do agree on that as well. And I think to really become a ML expert, in my opinion, is you should know the mathematics behind. I always stress that, because once you know the mathematics behind all these like ML algorithms and all this, right, you can sort of quickly pick up what are the pros and cons of the different machine learning models. And Oh, this is where it comes to there's another sort of myth that people have, and that is if the ML model is more complicated, right? The mathematics behind you don't really understand it. That's a model you go for, which is I have to say that is total BS. That is total BS. At the end of the day, I would say most of the all the ML models, right? What they do is like what Julia Pearl mentioned, right? Is you actually model the relationship between the target and the features. And there are tons and tons of different types of relationship, and probably some of the ML models that can only model a few of the relationship at the most. We may not even I would say we're probably still discovering more ways of like trying to model the relationship between the target and the features. But at the end of the day, I'll come back and say that I think we need to have a strong maths background first then you can read the ML algorithms. And then from there, like what Dave mentioned, I agree as well, and that is the business component as well. You have to translate that mathematics into the business value. Otherwise, where do you get your salary? I always stress on that. Yeah.
I'd like to answer this one as well, because I agree with all three of what everyone is saying. I would add on top of it, I would say the most important skill in general, not just for being an ML expert, would be critical thinking. So a lot of the times, let's say we need to apply machine learning to a certain business problem. A lot of people would just, okay, give me the data, I build your model. That's not critical thinking. What you want for critical thinking is, okay, you have to be able to ask the right questions. You have to, okay, why are you building this machine learning model? What sort of data points do you have? When are you going to use the machine learning outputs to how are you going to use it? Are you going to rank the top 10% of model scores and then you send them an email? Are you going to try and target the top 2? There's all these different things you have to consider. But I think these are they're like problem solving skills. They're not just, okay, I think I have this problem, I apply this method. I don't think that's what a machine learning expert is. A machine learning expert should be able to tell you what is the problem you're trying to solve and really confirm it with you to make sure that everything is clear. And then they'll be able to make the decisions of, okay, I have all these tools in my toolbox. Which one is the best fit for this purpose? I think that is more in my mind what the expert is, being able to not just troubleshoot and solve problems, but to be able to do it and communicate and get everyone on the right path at the same time.
Yeah, then can you maybe highlight the comments from David Martinez?
Oh, yep. Let me try and find it.
Okay. Yeah.
I
think so. Okay. So here's the point, right? I mean, if you look at it, like a lot of like out there, there's all these like boot camps and all this. But what they did is, all these are predefined already, right? All these are predefined. Even the target is actually predefined, no. But when I run courses and all this, right? And I speak to people, I ask them that, okay, can you define the target for this kind of problem? I give them a business problem statement. Generally, a lot of them actually get caught up, get too, how to put it, they don't know how to convert that into a sort of a modeling problem then, if that's the case. And that's one thing. Second thing is like what Danny just want to mention, right, about setting up the target. Whether you can set up the target correctly. Like for instance, I think one example I had recently was, I was asking them, let's say if you want to find out like whether a person will default on payment or not, how do you define default in the first place? So some of them was like talking about, hey, if you're talking about default, as long as it's past the due date, then probably you'll set it as default. But is that true? Is that really what we like to investigate further? Is that what we really want to be able to fish out from our machine learning models? And then that prompts them to think a bit more and say, yeah, actually maybe not really the case. So you probably have to, so that definition of that target, right, is actually something, unfortunately, it's not taught in a lot of schools, a lot of boot camps, at least from what I observe, but it's a very important skill to have. Yeah.
Can I add to that as well?
Sure.
So to give the audience another example, let's say in Ku's case, it was defaulting on a payment. Let's say for our example now, it's the day that someone lapses on their insurance policy. So the day that they leave your company and they go to somewhere else. The most common mistake for the machine learning practitioner is to take that date and try to get data from that date and prior to that. So when we think of in machine learning, you'll always have the target variable, which is like, let's say true or false, 1 or 0, maybe it's a value of something. But when we're working in a real life project where you need to generate machine learning features, there's always a date component. You will never be able to get data from the future, and you always need to look at data from before that date. So calibrating that date is super important, because not only does that define what sort of information you get to actually apply the machine learning, but it also defines whether it's a positive or a negative example. And there's one more component where, let's say it's for the, what am I doing again? The guy that leaves our insurance policy. If you take that date, that exact date that he leaves, you're essentially trying to predict that someone is leaving on that day, which is not applicable. Like, most of the time when you're running some sort of machine learning initiative in business, you don't have a day to turn around some email contact to go out to try and stop him from leaving. A lot of the time, what we like to do is to give it a larger time frame, and then you can apply some more statistical thinking to think about, okay, should I always try and predict that someone leaves on day 10, day 7, day 30? Do I have to set it on one day? I think that's where some of the math and stats really comes into machine learning. It's part of, like, I think it's a very often missed component, because not many people have that opportunity to actually go in and build a model from scratch to perform these sorts of, what I would say are quite stock standard prediction problems. Like, they happen almost everywhere in business. You're trying to predict whether someone clicks something, whether someone opens an email. All of these things will happen within a time frame, but we're not really taught much of it. You only learn it on the job, sort of thing. Do you guys have similar experiences with that, or?
That's where the critical thinking comes in too, Danny, as you mentioned earlier, right? Is to say, like, if you're going to build a churn model, you have to say, okay, I've got my positive cases, but what I need to do is say, I got to design features that are going backwards in time, and say, of all the people that churn, how many times do they contact customer service in the 6 weeks prior to their churn date? And then you pull a bunch of data from the people that didn't churn, and those become your negative cases. You have to think about that. And you're rarely not taught that in class or in a book, unless you find a specific book on churn modeling, for example, or something like that. I also wanted to talk a little bit about David Martinez's comment about dirty data and how he's not seeing that in his class. And that is, unfortunately, that is something that's hard to do, because to be quite frank, real world dirty data is typically intellectual property of companies, and they don't want to give it out to people to use, to learn from. So it's actually really hard to find realistic dirty data, because companies don't want to give it out. So you can find certain data sets that do have dirt in them. One of my favorites, which is a very simple data set, generally speaking, is the Titanic data set from Kaggle. It does have some dirty stuff in it. So, for example, you could look at the cabins. Some people have no cabins. Some people have multiple cabins. You've got to, like, work with that, figure it out. How do I transform that into features? How do I clean it up? It's a very small scale data set, of course, but it gives you some sort of flavor of what you see when you actually go work at a company. But generally speaking, getting a real large real world data set from a company is basically a non-starter.
I would like to add to that as well. I think setting up, besides thinking about the definition of target, right? And I think another thing that we also have to be mindful of is about the class imbalance problem. So if we set up the targets and all this, we also have to be a bit mindful about the class imbalance, whether we have enough of the ones and zeros to do the comparison as well. So I think that's another component I like most people to also pay attention to. The other one is actually a common problem, but I'm trying to find the keyword or the keyword for it. But what happens is I've seen a few people, right? What they do is when they build an ML model, they do not realize that they have to be mindful about like what Danny mentioned, right? Let's say if you're going to do the scoring on the maybe 1st of Jan 2020, you have to realize that you can only use features that is before that. But what happens is because the whole data was dumped on the student or dumped on the quote unquote data scientist, they sometimes will use features that is like that happens after the 1st of Jan 2020. But it's because the data set was given up to maybe June 2020 instead. So when they build the model, they did not realize that they are using features that is after the model scoring. If I'm not correctly, I think it's called what, temporal infidelity or something along that line. I don't know what's the actual keyword for that. But that's something that I also often see it as well. Yeah. Sorry, Danny?
I think we usually refer to as leakage or label leakage or feature leakage or time leakage. Usually it's something to do with leakage where something from the future happens to be in your data set when you need to make a prediction.
Yeah, okay. Okay.
Happens a lot.
I have a look. Yeah, I have a look. Yeah.
Okay, let's continue. I think there's a really good question here. Unfortunately, I can't see who it's from. But how important is EDA and research on the data prior to machine learning? In a nutshell, very.
In a nutshell, the most important thing.
It's not important at all. Just ignore it.
Yeah. Just throw another layer. Just throw another layer in your neural network, and it'll figure it out. That's fine.
Yeah, EDA is like way overrated. Just store your data into a model and forget about it. You're fine. Just kidding.
I think EDA is really, really important. A lot of people, or a lot of times I've seen people think of EDA as like, okay, you got to use like seaborn.core plot, and then they just plot the correlation matrix, and that's their EDA, and that's the only step they do, which blows my mind because I think that's what's being taught. Like a lot of people actually think that that's what we do for exploratory data analysis.
So I got to inject here 2 words, Danny. Anscombe's quartet.
Yep.
Wait, what?
If all you're using is a correlation matrix, Google that. Google it.
Okay, I need to Google that then.
Yeah, that's a good one. Basically, all the stats on 4 data sets look the same, but when you graph them, they look different. So that's what it comes down to.
The Anscombe quartet, is it? Yes. Okay. Yes, I remember that.
Oh.
Yeah.
Okay, I'm the only one out of the loop. Whoops.
The danger of relying on correlation by itself, right? Anscombe's quartet shows you that you don't want to do that. You always need to visualize your data in addition to creating the correlation stat.
But I mean, that should be one of the first things you do in your ML pipeline, though, is understand your data. I mean, there's a variety of techniques you can use for EDA. Graphing is definitely one of them. There's also other techniques. I would always run correlations on the labels just to make sure there's nothing outstandingly similar to the label, which is also usually the label buried in your data somewhere, causing leakage. So that, and just understanding also like data distributions, cardinalities, pretty basic stuff, right? In your data set, for example, like you don't want to have data that's probably too high of a cardinality because you're going to lose a lot of signal in there. Understand things like IDs, probably want to throw those out of your trained data because you're not going to need them unless you are going to need them. So just basic stuff like that. I mean, that should be your first step. It's basically you should understand your data. Like I know that we hit on this every single Data Heretics episode, but it's so overwhelming. I think if we're hitting on this a lot, you should be doing it. Like definitely understand your data, and we'll probably repeat that about 100 more times tonight. Because if you don't know your data, so I've worked on like auto ML systems where it was the whole goal was to be able to take any data set, apply machine learning, and get a prediction. I'm pretty sure you can figure out how that goes, right? So you can have all the sophisticated algorithms and ensembles and whatnot that'll find the best fit on the data, but if it's just garbage in, garbage out, or gold in and gold out, or whatever. But if you don't know the data going in, it's going to be really difficult to know if the model that's being produced is even worth anything. So,
I'd like to add so we can definitely plot things. That's really good. For me, one of the things that was really drilled into me was to understand where the data is coming from. So who's generating it? What sort of process was it generated for? Like for sometimes, like you might get, let's say you get reporting data, for example, that occurs once a month, and you think that it happens every day. So your model optimizes for daily feeds of this, but it doesn't actually change until the next month's worth of data, and then it breaks your model. So different things like that are really important. Sometimes I like to think about, so Joe was talking about distributions of data. That's usually my go-to. My number one is to look at let's say we're doing binary classification, so you have positive and negative class. I will just take every single feature and I'll plot the cumulative distribution for positives and for negatives from 0 to 100%, and look at the distribution of values and see if there's anything going funky in there. I'll also look at the max and min values for each percentile, because you want to identify outliers, whether a variable has a ton of zeros, a lot of nulls. All of those sorts of things are really important before you even think about doing any pre-processing to it. The cardinality is huge too. These days, there's a lot of things which you can do to, I think what we've done in the past is if you have something with over, let's say 100 levels in a categorical feature, potentially you could just throw it away. That was what we did in the past when we didn't have as much compute power as we do now. These days, I think you can there's different sorts of things that you can look into, categorical encoding. There are things which take into account multiple different combinations of features. So you might have, the most common one is, let's say Monday, Tuesday, Wednesday, all the way through to Sunday. There are some pre-processing steps where you can actually capture value to say, okay, this is weekdays where it's Monday, Tuesday through to Friday versus Saturday, Sunday. You might have Monday, Wednesday, Friday as another combination. If I'm not incorrect, I think that's called Fisher splitting. I can't remember the actual term, but it's used in light GBM, which is really popular these days. But yeah, there's all these different things you should think about from the raw data level before even contemplating, okay, what model, what algorithm am I going to use before? Yeah.
I think
And one thing I would add to that too is, especially in the structured realm, because we're tend to focus on structure here rather than unstructured, is context. Generally speaking, if you're pulling data from a data warehouse or a transactional database or even a data lake, all of the data has specific business meaning. The numbers, the categorical values, they all have a context based on a business process. And if you typically don't know that, you're flying halfway blind when you're doing your EDA. So don't underestimate that.
I would also add, on the notion of the data warehouse data, because I see this often too, when people will do machine learning on BI data out of a data warehouse. I would say 9 times out of 10, if you think hard enough about what you're trying to do, you could solve that with a SQL query. So there's cases, I think, where ML isn't even necessary. If you dive beneath the surface, because especially data warehouse, data in a data warehouse, that's data that's in there because there's been business logic modeling. And that data is in there to describe solutions and give you answers to various business problems. Time and time again, especially when I was doing AutoML, if you did it on a BI system, most of the time, it was not a machine learning problem. If you dug beneath the surface, maybe using something like 5 whys, just ask why 5 times. Why do you need this? Why did you say that? That's a good way of understanding what type of problem you're solving. And the other thing I'd add to that too is not every time series problem is going to be a machine learning problem, right? So you could use like statistical methods that have been around for a really long time to do forecasting. You don't need to use deep learning or like random forest regression or whatever. Like you can get away with using
ARIMA, man. ARIMA.
Yeah, ARIMA's great. Exponential smoothing. Like there's classic techniques that have been around for a really long time, and they've been used in industry and have made people a lot of money. And I think that there's a lot of value just sticking with the basics. I see nowadays, kind of going off on a bit of a tangent, where people will call time series forecasting machine learning. I subscribe to the belief that it's not, because machine learning is developing an algorithm that learns from experience and can be used in new situations. A time series model typically is extremely dumb. You give it a time series and it spits out a forecast, and that's it. There's no training involved. So just wanted to get on my soapbox for a second, talk about that. Anyway.
Todd is very happy now.
So, Joe, what do you think about logistic regression and linear regression then? Are they machine learning or not?
No.
Inquiring minds want to know.
Well, I think at the end of the day, I think when it comes to EDA, right, just be mindful that we are using the EDA to build towards the modeling phase, the model training phase. We're trying to like give insights to what we should do in the model training phase. I think that's the key when it comes to EDA. So like what all of you has mentioned about like outliers, the distribution, the lattice plot, the correlation, and stuff like that. At the end of the day, I think so why I'm talking about this was because recently I had to interview a few people. They are just beginners, but what happened was they plot a lot of all this like distribution, they plot a lot of this scatter plot and bar charts and all this. But at the end of the day, what they did was they just plot it, but they never sort of draw relation to the model training phase. It's like, oh, okay, I see this. So maybe during the model training phase, this is what I need to be mindful of and all this. But and that part is actually quite lacking, I would say. And I do not know why. I mean, I haven't really sit in the boot camps or courses and all this. But I suspect that's where the gap in the knowledge is again. Yeah.
And to riff on Joe's point as well, EDA might actually show you that you shouldn't be building a model at all, because maybe you find that, oh, wait a second, the data is showing me that I can put a simple if-else statement in, and that's good enough. That works great. Or alternatively, your EDA shows that you have no signal, almost no signal in the data at all. So it's extremely unlikely that an ML model will be robust enough to pick it up anyway. So maybe you won't even bother with it. So EDA is like the number one thing.
I mean, I was actually just talking with one of my old machine learning friends today. We were riffing on the curse of dimensionality, which is the notion that as you develop more dimensions, features, the signal from machine learning decreases, right? That's just how it is. So, EDA is incredibly important. What I've seen is like you throw the kitchen sink at this data set, add an algorithm, and then we'll just, see what happens. And what inevitably happens is you get kind of a shitty model.
No, Joe, regularization will take care of it. Don't worry.
Just
throw it all in there. Regularization takes care of everything. Don't worry about it.
Yeah.
Wait, which one? L1 or L2 then?
L3. That's fine.
L3. Can I add to the whole purpose of using machine learning is that we want to use the data to make a decision. Like somewhere in the process, someone has to action based off whatever prediction you're taking out. But when we think of the overall business consideration of, okay, do we even need to use a machine learning model for this? Can't we just use a simple if else? If we can see a lot of, like if there's a big insight in there, most of the time what we would do is just, okay, let's quickly run an experiment based off the insight and see what happens. If there's value in what we do there, then we can think about increasing the accuracy of whatever we're doing. So let's take, for example, you're sending emails, like marketing emails, and you're working for Amazon or something. So someone's clicked on, let's say, baby food items, or they're searching for baby food. That might be enough signal for you to send them an email to say, oh, have you considered these baby items? I don't know, something like that. As opposed to on the flip side, someone might go, a machine learning person might go, oh, you want people to be sent baby emails? Let me find out who I should send it to. And then they take like 3 months to build their model, to build their pipeline. Then they put it out into production, and it ends up with like very similar results to just someone clicking on a baby thing. Like,
or Or maybe you just use market basket analysis or something like that, right?
Yeah. Or
Yeah. I mean, I think you bring up a good point, though, Dave. I mean, there's a lot of techniques out there that I think go underappreciated because it's not ML, right? Like, there's a few of us that have been around the block. I think even before ML was the cool thing, in the 2010s, where there's like survivor analysis, market basket analysis. All these things aren't really ML, but they certainly get the job done, right? So I would say, I know this talk is about ML pipelines, but I would say also consider like broaden your horizons with different techniques, right? Not everything is an ML, one size fits all problem. I know that right now it's popular for data scientists to want to, use the ML hammer and attack everything that's an ML nail, but there's more to life than just loss functions. So
most of the time, people just use the preset loss function anyway. Like no one's crafting their own loss functions.
I think Joe needs to go in the bumper sticker business.
I'll sell a grand total of like 3 of them to you guys, and that'll be it. So.
Okay, there's one question here. We can talk about something practical. So I would like to know how to select features which are important contributors to the target variable. I think this is great. Who wants to? One of the most simple things to do is probably to fit a very simple model, such as linear regression, logistic regression, and look at the what's it called again? No, it just flew out of my mind. Yeah, that's it. That's the one.
Yeah.
Yeah. There's a bunch of techniques. So like, for example, if your target variable is categorical, mutual information is it's a nice little statistic to use. If your target's numeric and your predictor is numeric, simple correlation, but always graph it to make sure there's a linear relationship between the variables before you just trust the correlation score. And of course, if you want to go the model route, there's nothing nicer than permutation importance from the mighty random forest. That's a good, quick, easy way to actually get some sort of idea what's going on as well. Although I wouldn't start there. I would start with mutual information, correlation, do some data visualizations. I mean, I like ggplot too. That's my go-to. Box plots, colorized, filled histograms, bar charts with multiple facets. There's all kinds of things you can do to actually ascertain that without actually going to the ML hammer.
Mm-hmm. We got to figure too, your training time for a lot of these ML models is quite, it could be a lot actually, depending on the data set you're talking about. So, if you can get away with just using cheap things like regression, or I would just do that. Assuming your data is linearly separable, like Dave said. If it's not, figure it out. So
yeah, that's why I like the random forest, right? It's got nice nonlinear boundaries out of the box. You don't really need to worry about tuning it. It does pretty well just with the defaults, generally speaking. But don't go to ML first. There are plenty of other techniques you can use to do EDA to explore relationships between your variables.
Although, there are some other techniques, I would say, if you're trying to look for feature importance. I mean, you could use Lime. SHAP is another one. That's what Google's using now for its explainable AI. So if you want to go on the other end of the spectrum and get really wild, and you can take that into consideration. So
yeah, in R, for example, you could use the formula syntax and make it explode, right? So you could do x squared, x cubed, all that, run it through GLMNet, use it with some tuning parameters, and use regularization to find out which still has a coefficient and which doesn't. And because you're using polynomial terms, you're also going to account for nonlinear boundaries. But once again, I'm like, I wouldn't start there. But you can do it.
Cool. Do you have much experience doing this sort of stuff?
Yeah, but I generally actually agree with what Dave mentioned. So like box plots will be one of them. Correlation will be another. But again, correlation will be also you have to look at the distribution as well. So generally, I like to, if I want to look at correlation, I also look at the lattice plot, where you can see the individual scatters and see how it works. Because okay, the reason why I like correlation and lattice plot, right, is also like what Joe mentioned about the multicollinearity thing. If you do something like the correlation and lattice plot, you can immediately see whether there's a potential for multicollinearity issues as well. That's one. Then the other thing is about, what's the other one? I think I also like to see the plot between the continuous variable and the target, and that is the, I think it's called like homoscedasticity or something like that, where you're looking at the distribution along the x the distribution on y with respect to the x. So that's also the go-to as well to quickly see what are the other challenges you're going to have going forward when we build the models and we train the models. But I totally agree. That's why I think EDA is underrated in the sense that I think not a lot of people are like focusing too much on it, and everyone is like talking about ML and all this, and everyone jump into ML without looking at the data, and you don't really have like what I always advocate, right? You really should go and structure your own EDA and how your EDA process, and must remember to lead the EDA process to your model training process. I think that's the key that we'll like the audience to have. Like the audience to have, yeah. So go out there, set up your own EDA process. If you want, you can even automate the whole thing using R script or Python script and all. Then you can quickly all set up and start exploring the data and all. Yeah.
Yeah, I'd like to say for me personally, after you've gone through a few different machine learning problems, you build up a lot of code that's reusable. So in the past, I used to have like big scripts that I would just chuck my data in, and then it would just do all this magic, the machine learning, to actually give me some of the plots that I wanted to look at, some of the correlation analysis. It might even build me a very simple model so I can look at the feature importance. Then I can just hone in on the top 50 features or something and look at something that's going on. I've seen things where I've seen like machine learning for this purpose, just to extract the top features, be totally overblown. Like I've seen a process where essentially it'll train like 1,000 XGBoost iterations or LightGBM iterations of something, randomly setting a seed, and then it will aggregate all of those feature importances and then give you back the most important ones. But for me, it was just a waste of time and computation. And they were doing it on the whole data set. So it wasn't even taking samples and trying to run it on samples so it would run quickly. It was just do the whole thing and then take those top 50 features and train the actual model, which is like, it's a lot of, for anyone who's viewing and who hasn't had a lot of experience training large models on big data sets, that takes a lot of time. And you don't want to be doing that.
Yep.
Okay. Let me go on to another question. Let's see if we can find something else on here. Let's go for here. So when building machine learning pipelines, is there a process to define the separation of concerns or steps the pipeline is made up of?
Yeah, I'll take that one.
Yep.
Yeah, so, I mean, traditionally your pipelines are going to be broken up into several discrete stages. You're going to have your data ingestion, right? So, and then you're going to maybe have some sort of, back in the day, I think you would see like ETL in these pipelines. And again, it's talking about structured business data. We're more and more seeing is ELT. So actually like load your data into a staging area in your either your data lake or your data warehouse. Do your transformations leveraging the computational power of that system. Talking about something in the cloud, probably not something on-prem. And then from there, you optionally have there's sort of an arrow that goes to BI and maybe data that goes into your ML pipelines. Now, of course, there's other data sources that can come in, streams and whatnot, and we can certainly check on those. But yeah, your ingestion is just basically like batch streaming type of pipelines. going into a data source. Now, once it goes into the data source, this is where you can choose to do, like I said, analytics or machine learning. And from this point, you go into your basically pre-processing stage with your data. Maybe you're going to find the data set you're going to use for your model. You're going to train it, hopefully test it, and deploy it into some sort of a production endpoint, right? So again, like we were talking earlier at the beginning of the talk, it's like the endpoint could be used as like a REST API, where you can send API calls against that and get predictions back. This might be a batch prediction, where you're just simply, doing a batch prediction, batch results, and that's your data set. And so there's a number of things. Now, of course, that's just end-to-end to get the model. Of course, now you have things like monitoring. You would have, basically retraining mechanisms and countless other stuff. I can't remember the diagram. It was based upon Google's, the high interest credit card and machine learning data, or whatever it was called. But it was basically this diagram that showed like machine learning being this little like square here, and then all the other pieces that you have to consider when you're building a production machine learning pipeline. And so
so ideally to answer the question, there would be a nice, well thought out, and I know I'm going to sound like a broken record here, a nice broken out conceptual architecture that you would follow. And ideally, these conceptual architectures follow what's known as the SRP, the single responsibility principle, which gives you these nice separations of concern in the architecture for building out your pipeline. And then what you do as the engineer is you then take your functional, non-functional requirements for each part of that conceptual architecture, and then you map it to a potential technology that meets those requirements. And I know that sounds really simplistic and kind of old school, but it is kind of the way it works. Once people figure out conceptually how things are built from a best practice perspective, it then really does become this process of mapping a conceptual piece of the architecture to a particular technology and see if it meets your requirements, and then you're off and running.
I would say that it's like this whole principle is more around business analysis. So it's around understanding what are the different components and what technology, who is the owner, how they interact with each other. And none of it actually touches the machine learning. The machine learning is just one single box where the model is being trained. Maybe you have some data processes that's going on in the background, or Joe's showing something. Let me see if
that's a technical depth paper or something. Is that correct?
Oh, I can't make Joe's screen the largest one. He's trying to show some. We'll throw this up on LinkedIn later as a share as well. But yeah, I think oh, he's on mute. For the audience that's watching, just remember that machine learning in a whole big system where you're actually using machine learning to drive your customer experience or your product experience, it's just a small component. It can make a huge difference if done correctly, but there's a lot of other stuff that's going on outside of the actual machine learning, which you are like almost 100% dependent on to actually get your machine learning out into the real world. And I think that's why we're very passionate about trying to let everyone know that there's a lot of stuff outside of the machine learning just to expand everyone's thinking. Because I think that's the most important thing, just to be curious on how we can do this better.
Well, I would say that right now, too, is an interesting time in the ML ops space. There's a lot of new companies vying for different pieces of the ML pipeline right now, right? There's people doing and model debugging, observability, data quality and ML pipelines, profiling, and on and on and on and on and on. Like if you pick a space, I guarantee you there's at least 20 well-funded startups with highly qualified and smart people working in these spaces. And so, I mean, it's still early days, I would say. Like I said, I keep thinking back to like ML ops and ML engineering. It's where software engineering was at least 10 years ago, probably longer than that, right? And but I will also have an aside and say that if you're a data scientist and this kind of stuff interests you, this is a great time to be getting into a career in ML engineering. I mean, hell, I only think the title ML engineer has been commonly used in like the last couple of years. Before that, you were a data scientist, and before that, I don't know what you were. Okay.
Quant.
Analyst. Yeah.
Data miner.
Data miner.
You were a data miner back then.
Data mining specialist.
Yeah. A miner back in the 1800s. So, so yeah, I guess, point being, it's stay curious. There's a lot of cool stuff happening in the space right now. I'm talking to people all the time doing some amazing things, in the ML space, and has nothing to do at all with algorithms. Like somebody has a question here about how do you feel about picking the algorithm you're familiar with and fine tune it versus letting AutoML pick it for you? My opinion on that is more and more AutoML is going to be commonplace. I think unless there's an exception and unless you have a good reason to be handcrafting algorithms, I think in most business situations, AutoML will be good enough. Now, of course, there's a cost to it, right? You have to pay the cloud another set of money, but it's how the cookie crumbles. AutoML is getting pretty good, but again, you got to pick your use case. If it's something that's core to your business, I don't think I'd use AutoML, but.
Yeah, because this is what I would wonder too, is like, if you know enough about let's say, hypothetically, your favorite algorithm is the mighty random forest, let's say, and you know a lot about the business and you can engineer awesome features. Why? I don't necessarily know if AutoML is going to necessarily, it might give you a little bit of a bump, but is it going to be significant enough for the business? I don't know. That's one of the things you need to ask yourself, right? Mm-hmm. If you're relying on AutoML to counteract your lack of feature engineering, I would say that's a problem.
Yeah, that's a big problem. You got to understand your data. And I think AutoML is more useful when you have like unstructured data, actually. When you need to do stuff like image recognition, text translation, whatever. I mean, that's a solved problem at this point with AutoML. I would just use that. Unless you, again, like somehow your image algorithm needs to be customized, or somehow your translation or speech to text or whatever you're doing needs to be that much better or that much different than what AutoML provides. I would just use AutoML. Again, I'm making the delineation between unstructured data and structured data. Structured data, like I said earlier, is, I think, the harder of all the types of machine learning data sets to work on. But yeah.
Yeah, I'm thinking like churn models, underwriting models, stuff like that. I would be wondering if maybe you get some boost from AutoML, but I would think that that's going to be more a manifestation of you not knowing the data, not engineering the features properly more than anything else. Yeah,
unless it's something like a recommendation API or something where it's kind of a solved, like for e-commerce companies where it's like you have demand and you have users, and you can fit that into pretty well-defined parameters. In that case, you might want to try it, but I would definitely test it against whatever you could write and see what works best. So
there's like a new upcoming, I wouldn't say it's like a new field or anything, but a new engineering discipline, which is called prediction engineering. So it's all about like, how do you automate the generation of target variables? And I think the Nirvana, the ultimate state of where the auto machine learning should get to is, let's say Joe is marketing boss of some company and he has an idea of, I want to predict who does this. He clicks a few buttons and the machine learning system should generate that label for him, that target variable, then grab the features, then do the machine learning, then put it into production, then track it to make sure that it's training and retraining and not losing performance. That's where I think there's huge money if someone can try and put all of it together. But at the moment, there's just nothing in the market that has enough oversight to actually pull all of those different components and massage the data and get understanding of each unique customer's data to actually make that happen. So,
well, yeah, I mean, it's kind of like we were talking about dirty data sets too, right? Like every business's data is different. Before this call, I was on a call with a customer, and guess what we were going over? Their dirty data set. And it was gnarly, and it was very particular to them, right? Like no other company in the world has this particular data set. Just like everyone's fingerprints are unique. Everyone's data sets are somewhat nuanced. let's put it this way: if your data sets were all the same, like what competitive advantage would you have as a business? Because you're literally doing the same thing. Your actions as a business are represented in your data. So by definition, if everyone's homogenous, you're not doing anything interesting, assuming you're collecting your data. But so
continuing with that point, right? I mean, now if you have the auto ML, but I'll be aware, I'm not too familiar with auto ML, but based on the sound of it, there's also the other part about like which model to choose. Right, at the end of the day, even though yes, the top model can be maybe a simple logistic regression and all this, but there are other things involved. Like for instance, how about the implementation side, or maybe the regulators would like to look at a model and stuff like that. So that one, I personally, I feel you still need a human to look at it. Whether a human is a data scientist or not, that's a different story. But at least you need a human to look at it and decide that, oh, okay, at the end of the day, probably I need to choose a second best model rather than the top model instead. Even though the auto ML says that maybe random forest is the top one, but actually maybe the second one, the decision tree, is much better because it serves my business needs, right? It serves my business needs, and this is further accentuated, right, when, like what Joe mentioned, right, where each individual business have their own like unique business model, revenue, target market that they go for and all. So I kind of feel, yes, probably auto ML will start taking up the machine learning part, the machine learning training part and all this, but I kind of feel you still need a human decision at the end after that to choose the right model.
Yeah, not to put too fine a point on it, but if somebody develops a technology like Danny's describing, where it can go into an arbitrary business and you just tell it what you want it to predict and it can figure everything else out, I'm glad I'm living in Montana, okay? Because it's Skynet time. Skynet time.
Well, and then Bob here, he asks, like, what is the future demand for ML engineers, data scientists? How soon will this get automated? I think it sort of hits on daily living in Montana and stuff. It was interesting. A phone call I was on today. Somebody was describing, possibly, a new algorithm that would work on structured data better than existing AutoML. This is somebody I know has been working on this problem for a long time. So I'm curious to check it out. I guess the point is, it's going to be interesting to see what happens with sort of the evolution of algorithms, right? For the longest time, neural nets are written off as dead, right? And then all of a sudden, deep learning comes about, and neural nets are all the rage again. But when I got into machine learning, neural nets were a 4-letter word. AI was a 4-letter word because there had been AI winter, right? AI couldn't. There was a lot of promise, a lot of hype, and it didn't work. So when I was into it, I was getting into it like trees and support vector machines were all the rage. Right. And then along comes deep learning and the rest is history, right? You see this gigantic revolution happening, but I don't know that deep learning is the end all be all of AI or ML or anything. I think that it'll be interesting. I think you're going to start seeing old school techniques come back, like symbolic logic and representations, and maybe SVMs even once they're able to scale better. Who knows? It's mullets came back, so I don't know why SVMs
mullets are back
either. So.
Did you say mullets are back?
Yeah.
Oh, sweet.
Sweet. But the point is, so I guess your question, how soon will this get automated? It's hard to say, because what I've been saying is new techniques are going to come about, and it's really difficult to forecast the next 5-10 years of algorithms. I would say if you don't want to get automated, go work in algorithms research and secure your spot, and just designing the future. Design the future where Dave lives in Montana and algorithms basically run all business processes and and automatically sell to customers and to come up with new products and everything, because it might happen.
Yeah, I'm wondering if the question needs to be reframed a little bit, which is not so much what is the future demand for a specific job title, but what is the future demand for professionals that know how to drive business results with data. If you phrase it that way, I think that is bright, astronomically bright. The form of it might change. As Joe will tell you, back in the 1800s, I used to code COBOL, and things have changed since then. but I'm still writing code.
I mean, this is also true.
Yeah.
Sorry, I was just going to say with software 2.0, new buzzword, right? Where AI is going to write software. Who knows what that does to these job titles either, right? So anyway, sorry, Ku.
Hey, no worries, no worries. I was just thinking about the point that you mentioned just now about the algorithms comes and goes and stuff like that. So personally, I believe that the master algorithm that I think Pedro Domingos was writing about in his book, I believe the master algorithm will be a mix of all the 7 types that he mentioned in his book. If you were to go to the AGI part of things, but I kind of realized that, hey, machine learning, maybe, or even the data science or AI also have sort of trends, right, where people get so caught up in a certain machine learning model with forgetting about. At the end of the day, the bigger picture is what? The bigger picture is generating that value from data, and not see like, oh, I know this particular hammer now is getting like super hot, super popular. Let's just treat everything as a nail that the hammer can hit it on and all. Yeah, I'm just suddenly that thought came to my mind about these trends, because in business also, right? If you look at it, like maybe like periodicals like Harvard Business Review and all, they also have certain trends as well. Like, oh, nowadays you need to be like do digital. So I think the buzzword now is actually digitization in the business world. And also that's all these trends. Sorry, digitization.
What does that mean? Yeah,
I have no idea, because there's 2 words now. There's digitization and digitalization. I was like, okay, what's the difference between the two? To be honest, I like, as a layman, someone who was like our business and all this, they sound both the same to me, but apparently there was a difference between the two, though.
yeah.
I think one of them was related to tools or something like that. I can't. I got too much to figure out in data science already. I don't talk too much about the business terms. But I think here's the thing, don't chase trends. I think that's what we also like our audience to know, right? At the end of the day, yeah.
I think definitely. I'm with all of you guys. So there's definitely there's going to be a huge and only increasing demand for people who know how to use data to drive value, whether it's in the form of engineers, scientists, analysts. I think as long as the core focus is on being able to think critically, to solve problems with whatever tools you're comfortable with, to always be learning new techniques. I think those are the core tenets. And if you're focusing your energy to do all of those things within the data space, I think that's perfect. And that's where we need a lot more people working in this area. Like there's yeah.
I actually think I'm going to be a bit of a heretic and say I think there's going to be an increasing demand for people who also can operate in the gray area, right? Data is really good at answering yes or no questions, but I think there's going to increasingly be an arbitrage where, because everyone's focused over here on binary outcomes, for example, in business, nothing in business is really black and white. And I think as algorithms start making the business world more black and white, it may actually offer people in organizations or companies, new opportunities, maybe new competitive advantages, for example. So.
It's sort of like a false sense of security sort of thing.
Oh, it is.
Like,
it is.
We're using data. We're data driven. All our decisions are based off data. But if it doesn't drive value consistently, and you can't prove that your decisions are driving the value, then does it really matter? Like I've really struggled with that mental leap of we're using all our data, we're not measuring anything.
Right. So what are you doing?
Yeah.
So it's like now you just measure everything. Like, do you walk around your house with a tape measure all the time, just measuring things? It's like be kind of weird, right? So, but I don't know. But I noticed that there's a lot of people. I mean, there's increasing trend right now. Everyone's like, well, you got to be measuring everything. I'm like, well, I mean, it's good. You seem to be measuring what matters. As the old saying goes, what's the ROI of putting on your socks every morning? Right.
Hi.
So You forgot your sandal the other day, so
Yeah. Oh, that was a funny story. I missed a call with Joe because as I was getting into my car, my sandal fell off my foot, and then I drove home without my sandal, and I had to drive back to where I came from, pick up my sandal. Sorry, Joe.
No, it's fine.
What? Okay.
Totally get it. No, it was a funny story. You had to have been there. What other questions are we going to tackle?
All right. So I think we will do probably one or two more questions and then we'll wrap it up because we've been online for 90 minutes and probably whoever's watching the whole time, thank you so much. You're a warrior. This is a long stream.
Or a masochist, one of the two.
Yeah.
Or they're watching Netflix. So.
Yeah, just in the background. I think here's a cloud one since we're cloud pro. Should I learn machine learning using cloud platforms? As some articles say, companies are going rapidly to cloud. It's a must skill for data scientists. Your insights?
Take the one first.
Well, I probably disagree with whatever Joe says. So just
Okay. Well, okay. So here's a couple things. I would say. So running a GPU in the cloud, I would say for any long period of time can get kind of expensive, to be frank. So you may want to actually invest in a GPU and set up a GPU cluster on your desk. So it'll take up your entire desk, and you can just write your code against that. But I would say, so there's two discussions here. There's one which is like learning machine learning, right? And then there's the other one which is learning cloud skills. I would say, without a doubt, learn cloud skills. And by cloud skills, I don't just mean machine learning skills in the cloud. I would say that having good cloud skills in general makes you a better data practitioner in the cloud for a variety of reasons. The cloud is very different than on-prem, for example. Knowing how to do things securely, scalably, reliably, and cost-effectively in the cloud is a skill that you have to invest time into learning, right? And so even if my advice for a lot of people, if you're interested in the cloud, is study for like the easiest cloud cert you can get. In AWS is a cloud practitioner exam. I think in Azure it's the AZ900 Cloud Fundamentals or whatever it is, Azure. But like learn how that specific cloud wants you to do things, because they are all different in some ways. And then from there, I think you're equipped to start diving in and taking advantage of all the bounty the cloud has to offer. Now, keep in mind, cloud is also, like, depending on the stats you look at, maybe most businesses aren't in the cloud right now. It's still super early days. I think it's like 20% penetration. It's rising a lot, but it's still super early days. But inevitably, companies are going to be going to the cloud, and it's all the major advancements right now, especially in machine learning. You're better equipped to leverage the capabilities you have in the cloud and all the pipeline frameworks and everything else. So no downside to the cloud at all.
Yeah, here I would offer a little bit different of a perspective, not surprisingly, since we are 4 heretics after all, is that if you're getting started in analytics, if you're on your journey, you're starting in analytics, don't start in the cloud. Don't start in the cloud, because what you need to learn is the analytics first, right? The random forest algorithm is the same. The linear regression algorithm is the same. Statistical process control is the same. I mean, the whole bunch of stuff is exactly the same, irrespective if you're in GCP, AWS, or Azure. So learn the analytics first, and then say, okay, I'm interested in working at this particular company or that particular company, and they happen to be listing these cloud providers in their job descriptions, and then learn that particular cloud provider. But learn the analytics first.
Yep.
And I would say just do that on your laptop, because most of the stuff you can just do on your laptop. Unless you want to do deep learning, then yes, you need a desk full of NVIDIA GPUs, like Joe mentioned.
Get a fan too, if you're going to do that.
Yeah, Ben almost burnt down his house with Mr. Ben Taylor with his like rig of GPUs. Like, it just went on fire. So it's pretty scary.
I can see that.
Okay. It can happen, so just be careful, everyone.
You know what? That does not surprise me, Danny. That story does not shock me at all. Knowing Ben.
So I would add my thoughts on the cloud as well. So I would say for people who are, my camera is out of battery. Sorry, guys. So you just have to see my screen.
Okay.
Oh, interesting. Anyway, yeah. So where was I? I would say that if you're learning analytics from the beginning, from the get go, and you've not got much of a solid background in anything of the data, there are two ways. You can definitely just pick up the most basic tools and start from there. What I would suggest is to try and pick up the tools which will enable you to kind of like go cross-platform as easily as possible. So one of the go-tos for me would be trying to learn how to do things on Docker from day one, because we use Docker for almost everything when we think of production systems in the cloud. And you can load up RStudio in a Docker container or different things like that. But it's just the knowledge to know that Docker is there and that it's being used is something that is important that you won't be able to pick up by randomly reading different things. You have to talk to people, listen and watch our live streams and different things like that to get a wider perspective. But it's not always accessible to new starters because there's just so many things to learn all at once. So I would say really understand where you should focus in terms of, okay, do I want to work in data analytics? Do I want to work in machine learning? Do I want to work in the cloud? Do my target companies work in the cloud? And then kind of work backwards from there to try and figure out what you need to learn and where you need to learn it. But I think, yeah, I'm very bullish on the cloud as well. Having worked there for a few of my past roles, I think it's really great. It just enables you to do a lot of things really efficiently. Okay.
Yeah,
cool.
My personal take now is more of, I think there's still a cloud war ongoing now. So you just have to be a bit mindful, like which cloud platform you're going to choose to start learning from first. I think given the fact, like I said, I think I kind of feel, at least in Singapore, what I've seen, right, is there's a strong competition among the cloud providers. And with that in mind, there will be a lot more sort of changes on the interface, the features available and all this. So if you're going to pick up on cloud and all, just be mindful that it's a continuous learning. And also that the platform that you choose ultimately may affect what may impact your career later on as well. Yeah, I mean, now you have the three major players. I won't be surprised if slowly will just be like two major players instead. Yeah. That's my take.
Yeah. But I mean,
Which two, Koo? Which two?
Who's gonna?
No, don't put me on the spot, okay, Dave.
Chris has got me good on this one. He said night falls quickly in Australia. So my camera went dark. Very good.
Joe, you wanted to add something on it, or?
Well, yeah, I think with cloud though, I would say evaluate the three clouds. They all offer a free tier. GCPs, Google Clouds, I think is the most generous of the three. They offer you just $300 for 12 months. Azure has what is it, like $200 in credit for like a month or something, and then AWS has just an ongoing free tier that you can use. But I don't think you can go wrong with any of them, frankly. I think it just depends on what fits your workflow the best. I mean, they're all great. And that said, too, I mean, there's a lot of great open source projects too you should check out. Like I said, there's all kinds of new projects. You got your mainstays, PyTorch, sklearn, stuff in the R world that Dave knows about, and just kidding, dplyr and all these others. But I mean, you're sort of in this golden age where I think there's almost too many frameworks in a way, right? There's too many options. So it's best to, I would say, to answer your question of how to get started in machine learning, excluding cloud, right? Like definitely, like everyone said, learn analysis, learn the basic techniques, but then pick a problem that you're interested in, personally interested in solving. I think that's the best way to learn anything, is you have to have a vested interest in the outcome. If you're just going through tutorials, I mean, you're gonna forget what you learned in like 6 months, right? Unless you're actually applying it to something that you care about, it's going to be really difficult. So like have a goal, have an outcome. When you buy Dave's course, like think of like how you're going to apply that those lessons to something you're trying to do at your job or trying to do something that's maybe a hobby of yours. But like, the thing is like I'm still learning new stuff all the time, right? And part of it just because I'm naturally a curious learner. But on the other hand, it's like I have things I need to apply these learnings to, and so it always keeps you interested. And I think as you start learning more, you'll get more skills and learn more. I mean, hell, I'm looking at this machine learning book that I learned machine learning on that's from the 90s or something, and like that's kind of how you learned back then, is just like reading. So you have it way better than all of us. You can clank at a keyboard and try things out. That's pretty cool. So
I think for anyone who wants to learn some of the cloud skills without having to set up all the platforms, I usually recommend people check out A Cloud Guru. I forgot the final ending, but that's really good.
That's a Cloud Guru. Yeah.
Yeah. So there's, I think, one of their subscription tiers you can pay monthly. They give you unlimited sandboxes, so you can they set up invisibly in the background like your environment on Azure, GCP, and AWS, so you can play around with real environments. I think that's what you need to do if you really want to learn the cloud skills. Like you need hands-on experience playing around there and knowing what not to do and learning the right techniques. So I think that's really important. But yeah, there's, as Joe was saying, there's just a lot of stuff to learn, like not just within the cloud, but within machine learning, even within specific applications of machine learning, there's like just a huge amount. And so for anyone who's feeling really overwhelmed that there's just so much stuff out there, just know that for all of us, we're still learning every day. Like there's tons of stuff that we don't know. Like we don't know much more than what we do know. And we know that.
No, I mean, the amount of stuff that I think any of us don't know is far greater than the amount of stuff that we do know. I think that's empirical facts.
Yeah.
So, I mean.
Yeah. Cool.
So, yep.
Any final thoughts, Ku, before we wrap up this one?
Yeah, I think I'm okay with that. Yeah, nothing that. Yeah.
I think.
Okay.
Dave, do you want to plug your courses? Might as well.
Yeah, myself, Dave.
Oh,
yeah.
Oh, sure. Okay. Yeah. So I have a couple of courses, one of which is free. You can go to my YouTube channel. Just go to YouTube and search David Langer. I'm the first guy that comes up. And it's on SQL. So it's aimed at people with no programming background whatsoever, but skills with Excel. And it uses your knowledge of Excel to teach you SQL. I also have a online course now that I'm selling, which does the same thing, but for R. It assumes no programming background. If you have Excel skills, it teaches you how to do data analysis with R programming, just using your Excel skills as a teaching vehicle.
Awesome.
It's awesome.
So yeah, everyone, please check out Dave's courses. I'm working on some stuff myself as well, but I haven't made any announcements or even thought about when it's going to happen, but it will happen soon, hopefully soon. So just keep an eye out on my LinkedIn. Follow all of us if you aren't following already. We're pretty active on the comment section. So if you have anything on any of our posts, just tag us and ask us a question. We're more than happy to reply. Yeah. So yeah, I hope everyone had fun. We went for an hour and 45 minutes, just about. So thank you to the warriors who stayed with us the whole time. And hopefully we'll do this soon. Probably like straight away in the new year, we'll try and set something up and we'll make it at least monthly. Yeah. But yeah.
Yeah, definitely.
Yes, that'd be awesome.
Yeah, thanks to the audience. I hope you learned a lot. So we'll see you next time.
Yeah.
Yep.
Take care,
everybody.
Okay. Have a good one.
Okay, bye-bye.